All right, so this will be a view for you. So let me go to the first slide, and then we're ready to get started. Very good size TV, really good size. This would be nice to have a TV like that in home, back in home. Okay, so welcome to course that is entitled Simulation Laboratory Course. And remember when we met in last semester, I made a little bit of marketing work, and I said that this is clearly the best course organized in this university. Remember, I clearly mentioned that if you make a list of good courses in this university, what comes first is simulation laboratory course, then comes nothing, and then slowly other courses like simulation of mechatronic machine. That's where we met when last semester. And now we'll see then. So I promise that this will be a good course, and I wanted to keep this as a something that we think about matters and subject matters related to simulation, but we're also going to discuss about other topics, something that I feel that it will be beneficial to you. There will be one lecture or short, if not the full lecture, at least a short talk that is related to carrier console. So I'm planning to explain pretty much all the knowledge that I'm planning to give, all the knowledge that I have for you to make the full benefit for your career. And that's the plan to this course. And it's a lot to say, and we'll see how well we will accomplish this. There are technical matters as well that we will discuss. And this course will get started from those technical matters. So we will get started by looking at how is it we can model spatial bodies and how is it we can describe the kinematics in three-dimensional case. Then we're also going to discuss about how is that we can describe deformable bodies. That subject is very broad subject, and it would take quite a bit of time to explain all the details related to flexible bodies, but we can just scratch the surface a little bit, and hopefully you will get a good picture what is needed in order to model flexible bodies. Then we're also going to discuss a little bit about the contact modeling, and the good part of this course is the fact that I'm planning to use a lot of visiting lectures. There will be a first visitor that is coming within a few weeks. He's coming from Delft Technical University. How is that? Delft University of Technology. Delft University of Technology, right? The famous one, maybe the most known in Europe. How that is called? Delft University of Technology. You have never heard about it. Anyway, so the first visitor will be coming from that university, and his lecture will be related to vehicle model. So we're going to look a little bit about how is a different kind of vehicles can be modeled, and then other topics that the visitors will explain to you are biomechanics. We also look a little bit of product lifetime management, which is a business perspective for us. And then what else? Then really the heavy finite element computing. There is another visitor explaining that to you. So at least 4 visitors, maybe even more than that. So hope you enjoy. Okay, and then really the important thing is that this is not like real lecture in the sense that it was in a previous semester. Remember how it was in a previous semester? It went such that I was explaining and explaining and explaining. You guys were sitting. We can do it that way too, but I'm hoping that you will be active this time and you will challenge me big time. Like really challenging. Okay, what about this? What about that? And what about this? Because we can discuss whatever you want. Also related to your career perspectives. So use this opportunity, challenge me, discuss with me, get to know me better. How that sounds? I know that there is a lot to ask because this is not the typical way to go on, but if needed, I can put the recording off every now and then. So if you are afraid to ask a question that ends up to be in the YouTube, fine. We can close the recording, we can close the streaming every now and then have a good discussion. Okay? And you know how it goes. In YouTube, there's no way to recognize who is asking what. Because, camera is pointing to me, the mic is, close to me. So even if you ask something, online participants are unable to hear you. And that comes to recordings as well. Okay. So again, my name is Aki Mikkola. You know me all. So you all participated that class that was entitled as a simulation of a mechatronic machine. Correct. Okay. So anyone that did not participate in that course, you all were participating. That's good because we're kind of building this course top of that simulation of a mechatronic machine. It's possible to participate this course, and it's possible to complete the course without prior knowledge on simulation. But it will be a little bit of rocky road, and it needs a little bit of commitment more than usually. But still is possible to do so. So even if you haven't participated in the previous class, fine. We can make some tailor-made arrangements for you. And with that, it should be possible to pass this course as well. Okay, so I'm your teacher together with Perttu. The Perttu is a guy that you met already last semester. He was the guy that organized all these guided tutorials, and he will be with you in this class too. And based on the feedback, I haven't received the full feedback yet, but there was this instant feedback option in a Moodle database, and based on that instant feedback, I received, say, a little less than 10 inputs. And based on those 10 inputs, it seems that you guys like Perttu quite much. So he was many mentioned that he's a clear, good teacher. So he will be with you again. All right. So if you want to contact me, please send me an email. Or if you wanted to meet me in person, my office is located in the building number 6th, 7th floor, and the office number is 6729. Okay. And of course, all this material, like in a previous case, everything will be available in a Moodle database. Okay. So, how is this course then? What is an objective of this course? Why it makes sense to participate in this course? And now these objectives are categorized to 3 different categories. The first one is clearly related to technical matters, and it says that you will learn to use simulation tools in a product development processes. That's what you will learn. And we're going to learn a little bit about the project work as well. So not just how to accomplish the work, but looking at the big picture too. And that's something that we'll get back a little later once all these theoretical aspects are covered. But we'll look a little bit about, like I mentioned, a little bit about the spatial bodies. And that's something that is good for you to know because, everything is, of course, spatial. There is no such thing like planar case in real life. And how to describe everything in a 3-dimensional space, that's where we will get started even today. And then we're going to look a little bit about the flexible bodies, and then we'll really look how is the relation between the simulation models and reality. And then this time, the challenge, this course, one of the challenges is to learn the critical thinking against computer simulation. Remember, there is this medical condition called simulation disease, severe medical condition, which we have to avoid to get it. But you can easily get that disease because, we are all surrounded by simulation. And what easily happens is that more and more everything will be based on simulation. And less everything will be based on common sense. And of course, it should not be like that. Because what the simulation is offering us ability to learn. So it really needs this common sense. So what I'm emphasizing in this course is the use of common sense and not to try to catch this medical condition called simulation disease. All right. Then we also, really the big deal in this course is that we are looking at different techniques, not just the multi-body dynamics, how like was the case in the previous semester, but this time we're going to look at the different kind of approaches, and we're going to look like something called co-simulation, which means that we're combining different kind of simulation disciplines to one package and try to solve different kind of disciplines simultaneously. And that's particularly what we're going to do in this course. And an overview about the vehicle modeling, contact modeling, finite element method, so on and so forth. But really there we are combining things together and we're looking at the big picture rather than the details. Of course, a little bit of details too. How it sounds. Of course, I'm not expecting you to speak to me yet, but believe me, end of the course it will be just, very live discussion, group hugs every now and then we're gonna sing a song, and then we're gonna again explain something. So it's gonna be more like family get together rather than a lecture. All right? All right, so let's see what else I have. We are doing one simulation work, and the one simulation work is something that Perttu will explain to you on next Friday. We'll get back to practical matters in a minute, but there is one simulation work, and this will be a part of, this will be 50% of your grade. So only 1 divided by 2 of your grade will be based on theoretical aspects. Others will be based on what you're actually going to do and how is that you're going to write a report. And we're hoping you to learn a little bit about the skills that are related, how is it you can express yourself in a scientific manner. Okay, so we are not going to get back to this, but Perttu will get back to this on next Friday. These are the topics that I'm planning to teach to you this semester, and like you see, we get started in a hard way. So again, 3-dimensional multi-body dynamics, then flexible bodies, model reduction techniques, and that's about it. Those are the main subject matters that I'm hoping to cover prior to first midterm exam. Then guess that this is what will have followed in the second semester. These are related to tutorials. We are not going to cover that, but we will get back to that next week. What are the requirements to pass the course? Well, you have to do the simulation work independently. You have to do it in an acceptable way, and that will be half of the grade. Second half will be related to written exam. Written exam is very different than it was in the previous course, because in the previous course it was about online exam. This time is a conventional exam, in a way that you have to enroll the exam, you need to go there in person, and you need to do that by using pen and paper. Good news related to exam is that I will let you know all the possible questions well before the exam. Actually, how it goes such the way that now today when we are moving to 3-dimensional kinematics, I will let you know the questions, word by word questions that I might ask in written exam. There are not that many questions. There are, let me think, a total of, 40 questions? And then I will select 6 out of 40 that will appear in written exam. And then because this is, friends get together, you also have a power to select something. So you have an opportunity to select one question, and then you have an opportunity to take one question off from the list. This has to be based on your voting, so it's not the individual case, but just when we are entering the midterm exam, we will have a discussion. And in this discussion, you can vote one question that will, for 100% certainty, will be in exam. Another that you will take off from the list. So if there is something that you feel that is very, very difficult, and you have absolutely no idea, you can take that off from the list. Okay, how it sounds. And then this is a promise to you. So if I say word to word, I'm not gonna change. I'm not saying like, okay, there are questions related to three-dimensional kinematics. No, nothing like that. But it's like word to word what I will ask. So if there's like, okay, so what is the difference between Euler angles and Euler parameters? Word to word question like that might appear in written exam. So I'm not gonna twisting the rules. I'm not gonna try to modify the question, but they will be as they are explained over in today. Okay. All right. So then how it goes. So here is a formula for you that tells you how is a final grade. Let me see if I have a drawing here. Okay. All right, so here's a formula for us. I forget, by the way, I forget my pen back home, so that's why I'm using my, a little bit old-fashioned way to do a writing. So simulation work, that will be one part of the equation, then that will be combined with the written exam, and then we will take an average out of that. And again, we will round that up. So let's say hypothetically you will get 3 from simulation work, and you will get 4 from written exam. Your final grade will be 4. It's going to be 3 and 4, so it will be rounded up, so it's going to be 4. So then there is an opportunity to upgrade your grade, and that will be based on in-class quizzes. So if you do all the in-class in an acceptable way, I will explain the details again after a few slides. Then it's possible that you can upgrade that by 0.5 points. Somebody's trying to call me. Hopefully this is not related to streaming quality. Anyone have a computer or something that can check how is the streaming today? Because sometimes what happens is that the students are calling me or texting me. Voice quality is not good. You are not explaining things in a proper way, so I'm not understanding you. Okay, but hopefully it will be fine. It looked to me that it's fine. I'm gonna just check my this one. It seems that it's all right. Seems that no problem. But if somebody can check that out, that would be really, really great. Okay, so the lectures, those lectures, the live lectures will be on Mondays. This week was a special week. I guess this is because of New Year's holidays. So from this on, the lectures will be on Mondays, and they will be in this place, which is inconvenient place. Look at the place. I don't know how many 100 people can squeeze in, but too many for us, because the latest what I checked was that there was 42 students enrolled to this class. We don't need this big place, but it is what it is. But if we can make it this way that you guys are sitting close to me, that would be very nice. Okay. Then tutorials will be on Fridays at 10, and this is the room, and they are not getting started this week, but next week. There will be some kind of announcement that we will email to you or send it to you via Moodle a little later, but not this Friday, but the next Friday is the first tutorials. And no mandatory participation. So if you are busy, fine. Don't let me know that you're not coming to lecture. Don't let Pertutu to know that you're not able to participate in tutorials. That's your freedom to do whatever you want. So you can do whatever you want, except we're hoping you to do things in a timely manner. Now, when saying timely manner, what we learned from the previous semester was that sometimes there are problems. Sometimes, life is hard and so on and so forth, and you're unable to meet the deadlines. And this can happen. But if you can let us know prior to deadline that I'm facing difficulties, I'm unable to do it within this timeline, can I have an extension? We can provide you an extension. That will be fine. But remember it has to be prior to deadline. If you're approaching us after deadline and saying, my life is like hell, I cannot do this and that, and that's, why I'm late, then you're just late. We cannot help you if you're approaching us after deadline. Okay, so in-class quizzes, so this is a business as usual, you know how it goes. So we have a total of 25 points. And, if you're able to score 14 out of the 25, I'm going to give you that extra 0.5 points, which automatically upgrades your final grade by 1 number. Again, how it goes, keep in mind that, of course, theoretically it's possible to get 6 out of 5 from this course. Because you get here simulation work that is a 5, you get written exam that is 5, that will be, average will be 5, and then in-class quiz is 0.5, that will be theoretically 6 out of 5. That's not going to happen. So it's going to be 5 out of 5, that is a maximum. How is my streaming, by the way? Was it all right? Good, thank you. All right, so then, then the mid reports. So the mid reports, we will get back to that next week. But we are forcing you to start working with the simulation assignment already when the tutorials get started next week. And this is for your sake, because if not forcing you, then what will happen is that you will take really relaxed way until the deadline will approach. Once the deadline hits to you, then your life will be miserable. Well, your life might be miserable anyways, but still what we're hoping you to do is that you will learn the technique that you get started already when the assignment is available. So slowly you do something and you kind of demonstrating your progress. And we are setting some kind of like mid-report deadlines, and those will be available in a Moodle database. And then you have to send us a report and explaining some of the details related to your simulation work. And then this will be a report that will serve as a final report as well. So we are not expecting you to do multiple times the one task, but just keep on working with this assignment starting from the very beginning. Okay, so again, details will be available next week, and everything becomes clear to you when Pertti will explain you the simulation assignment. Okay, clear. So these are the deadlines. What week is today? Is it like week 2 or week 2? Okay, so it's just that we would like you to see your commitment in the very beginning. Look at that. So the first tutorial will be available next week, which is a week 3. And then the midterm report is due week after that. But we just wanted you to do something, to get started. And again, if you are able to do this, let us know so we can be flexible. Again, we can be flexible prior to deadline. After deadline, it becomes difficult. Okay. All right, but again, details a bit later. But then, what is the material? Same deal than previously. Even when you know all the questions. To answer the questions in a satisfying way, the material that you need is the material that is available in a Moodle database. There are mentioned that there is a book, Ahmed Jabana's book, that is a part of the story, but we are not expecting you to read it. If you wanted to get more deep understanding, go ahead and borrow that from the library and study by yourself. But we are not expecting you to do so. Everything will be available in the Moodle database. Okay, then let's look a little bit about the introduction. By the way, is pretty much everything clear? So do you know what I'm expecting you to do? Summary is this. So I'm expecting you to do the simulation work. Okay? I'm expecting you to do the written exam. How is that you can do the simulation work? Well, you can do it in such a way that you will submit the mid reports timely manner. There were a total of 3 mid reports and then the final report. And we are targeting this task such the way that well before the, this Labor Day party that is 1st of May, everything is already covered. Because, here the Labor Day party start already, what it is, like 2 weeks prior to actual day. So then you have enough time to do drinking and parties, no worries about this assignment. And then other tasks as well. All right, so simulation of work and then written exam. You can do it again by using 2 midterm exams. They will be conventional midterm exams, such that you need to make an enrollment. You need to go there in person. Then you need to write it using pen and paper. Last year, some of the students, I think they were exchange students, they had a little bit of hard time to participate in the midterm exams. So even we organized a special midterm exams, such that it was not exactly the time that the conventional exam was organized, but another time. So even that is possible. So we try to be as flexible as possible. So 2 requirements, written exam and simulation work. And then if you want to upgrade your final grade, the best way to do that is that you can simply do the in-class quizzes. This is obviously the best way. Every now and then what happens is that, a student approaches me and is saying that I'm not happy about my grade because I was scoring 4 out of 5. And I want to upgrade that to be 5 out of 5. Can you give me an extra assignment? And sometimes we do that. But sometimes we give an assignment that makes no sense to do it. I mean, if you look at how much energy is needed to do the assignment, it's absolutely nonsense. But we wanted people to, and the student to understand that, the best way to score high, best way to do things is during the course. Later, it will be a very, very rocky road. Another thing that is good to know, if you score 4 out of 5, that is considered as very good, isn't it? So it's like very good. So how it goes? 1 is like, I don't know what is a written statement for 1. Is it like acceptable or fair? Fair, passed. Satisfactory. 2 out of 5, what is that? Like fair, 3 out of 5 is good already, isn't it? 3 out of 5 is good. 4 out of 5 is very good. And then the 5 out of 5 is excellent. 4 out of 5, very good. Think about it, very good is already very good. And no one really cares that much about your grades. But we get back to that when I'm explaining this matters of career counseling to you. All right, so introduction. So really what we're doing is that here in this course, we're combining things together. So we're combining matters like, of course, 3-dimensional drawings that are, CAD drawings, finite element modeling, control algorithms, hydraulics, multibody dynamics, and so on and so forth, the one package. So we really would like you to take a look at something that is very much in fashion, and what is very much in fashion is a co-simulation. Co-simulation means that we have special tailor-made softwares for one particular discipline, and these softwares can be combined together. And that's what we're doing here as well. And there are many different ways to carry out this co-simulation. We're going to look at a little bit about these different ways. But really, if you think about the picture that was in the very first slide, that's what we always following. This one here, mechanisms, actuators, control scheme, so on and so forth. Now we will do this, but using different softwares, and combining these softwares together. That's exactly what we are aiming in this class. Okay. All right. So then here, and then we're gonna look a little bit about the details too, and I'm explaining, trying to really to tell you how is my perspective regarding how is the future of the simulation. And this is already the picture that I showed to you in last semester, but we're gonna look at what is available, what are the tools that are available in the near future, and what is that you can describe something very challenging using the computer simulation. And this is where I'm using my knowledge that I have learned from the scientific meetings and try to explain my views to you. So try to take the full advantage of that too. And then we're going to look at a little bit about how is that we can, cross the lines, and how is that we can help people from welding technology to use the simulation. Because in welding technology, one of the major problems are associated to fatigue, and we can help people to make up fatigue predictions. How that will be carried out, that I will explain you a little later in this course. But we are not looking at one narrow field, but we really wanted to give you as broad perspective as possible. Okay, then what else? Then we are looking a little bit about the contact modeling, like, let me see if I'm able to. Animations are not able to go. So here is like few cases, like simple cases, the bearing modeling, how is that you can model the bearings. And then there is a lot of examples, like really fascinating examples, how is that one can analyze the systems that consist of one very big vehicle, often military vehicle, that is then running with the very small parts. I will show you some animations right after the break. Okay, so this person is trying to call me already third time. Hopefully, don't know what it is, but the flexible bodies. Okay, but let's get started from the three-dimensional kinematics. These are the questions that are related to this subject matter. Now, if you look at the questions, there are, number 2 is coupled simulation. We haven't really touched that yet, but we will a bit later. Then, what kind of system can be analyzed using multibody system dynamics? We will not discuss about that today, but we can slowly get started. And this is how it goes. Every time we're moving on the new subject matter, I'm first explaining the questions you might see in a written exam. And again, how it goes. From this list, I'm going to use a lottery of some kind to select few of them to be in a written exam. And then you will select the one out of the full list, and you will eliminate the one from the full list. Clear? Okay, good. So, but like, why rotations are more difficult in spatial than planar case? That's something you can learn today. And then the second one, how the angular velocity vector can be computed in spatial multibody dynamics. You're not going to learn it today, but a little later. Explain the concept of Euler angles. You can learn it today. Then explain the gimbal locking. You can learn today too. Then concept of Röpke equation that you're going to learn today. And then concept of Euler parameters. Maybe if we have a time, you can learn that too. But that's about it. Okay. And again, no need to write this down, no need to take a picture out of this, because, of course, this will be available in a Moodle database right after our lecture. Okay, so you know this already. This is what we discussed, and we spent, 3 months to discuss about multibody system dynamics. So business as usual. So you're very much familiar with this. The multibody system dynamics is a multibody system. So we're getting this way is a mechanical setup or dynamic system that consists of multiple bodies, and the bodies are connected together via joints. The joints are really playing inherent role in multibody dynamics, because everything will be built around the joints. How to describe these systems or these components that are eliminating the motion possibilities between neighboring bodies. That's what the multibody system dynamics is about. And now, there are many different ways how we could describe the equation of motion. You already know the method based on Lagrange multipliers. You already know the method based on coordinate partitioning. But in addition to these two approaches, there are many others. We are not going to touch them. We're going to simply look how is that this description of equation of motion we already know, which is based on Lagrange multipliers, what is needed in order to extend that to spatial case. And we only look at the highlights. not really the deep details. All right, so like, this too as well, in a multibody dynamics, we don't make any assumption regarding the magnitude of rotation. This is very important to understand, because in multibody dynamics, the bodies can have large rotations. And if you have a large rotations, then that automatically leads to trigonometric functions, or the usage of the trigonometric functions, cosine and sine. And if you have cosine and sine in your equation, then you will have nonlinear equation of motion. So it's not about the linear dynamics we're dealing with, but nonlinear dynamics. And if you have a nonlinear equation of motion, generally speaking, there is no analytical equations available. So we have to solve the response by solving the equation in forward of time. So that's what we're doing in a multibody dynamics. And of course, this is a little bit a matter of an opinion. It says here that the multibody dynamics is a straightforward approach. I don't know how you feel about that. Is it straightforward or not? Well, of course it is if you're using, just the computers and not looking at the theory. Of course, the theory can be a little bit rocky, but, well, generally speaking, it's quite straightforward. And it can be applied to a wide variety of applications. Okay, now what we can do then is that we're going to refresh your mind about the Euler angles, and then we're going to move on to something else. And what we're going to move on will be the method where the rotations will be described by using four parameters. Four parameters, correct. And what are these four parameters? Well, there are many different ways to describe them, so it really depends on the method we're going to select. You will learn to use two methods. The first one is going to be called Rodriguez equation, which is like the mother of all these methods based on four parameters. And then its variation, which is called Euler parameters. Title, Euler parameter is very close to Euler angles, but these two things has not much to do with each other, so they are completely different approaches. Again, keep in mind that what is a number of parameters I'm describing, and I will get started with the three parameters, which is very straightforward, as the body can rotate in three different ways. Makes sense? Then I'm going to add one more parameter, because there's a clear benefits to add one more parameter, and then we're going to deal with something completely different. Again, keep in mind that I'm not going to claim that the body can rotate in four different ways. So it's going to be three different ways. But mathematically, describing the body rotation in three parameters is difficult. So that's why I'm adding one more parameter, and that's what you are about to learn. Okay, so now three-dimensional body is what we're going to get started. And you know how in a three-dimensional body, the description, or maybe we go here, the description what we really wanted to do here is that we wanted to describe a particle with respect to global coordinate system. And in spatial case, the concept is exactly the same how it is in two-dimensional case. So we will use this body reference coordinate system, and with help of body reference coordinate system, we will use a vector U-bar to scan all the particles within the boundaries of the body. So that's how it goes. Now, no difference in 3D comparing to 2D. Only, clear difference is, of course, the fact that now we have more dimensions. One additional dimension. Nothing else. Now, what that will lead when we are using the one additional dimension? Well, it means that now let me try to write this in a clear way. No. You know what that is? Omega. So that's, in planar case, the angular velocity is a scalar value, because the angular velocity can take a place around one axis only. And that's the axis that is coming off from the plate. That's where the angular velocity can take a place. And now, in planar case, angular velocity is equal than time derivative of generalized coordinates. Well, this is really unclear, but you know that we have, in planar case, we have, for one body, we have 3 generalized coordinates. And those generalized coordinates are r1, r2, and theta. And now if I differentiate the theta with respect to time, I will get theta dot. And that's exactly the same than angular velocity. 3-dimensional space is more complicated than that. And that's where the big difference comes from. Because in 3-dimensional space, angular velocity is a vector. Vector that consists of 3 components. These 3 components can be described with respect to body reference coordinate system or global coordinate system. But the big difference is this. There is no way to describe the angular velocity by differentiating the angular coordinates of generalized coordinates. So that's not equal. Those 2 things can be related, but they can be related a little bit of complicated ways. And this is a big difference. Here comes the good news, because I'm sure you hear me like this. Angular velocity, generalized, like no one understands, like what the heck? Come on. Fine, because I will explain this in details to you a bit later. But shortly speaking, the big difference in a spatial case is related to angular velocities and how they are related to generalized coordinates. That relation is complicated in 3-dimensional space. Surprisingly enough, this is still a matter of research. If you look at the papers that are in the field of spatial kinematics, people still looking at the ways how the kinematics in spatial case can be described. So it's still an active research field. Even though that is clear, body can rotate in 3 different ways, mathematically you can describe in this and that way, but people are looking at the more efficient way to describe the body orientation. It's quite surprising. But anyways, no, it's a bit more than 45 minutes, so can we do such that we will have a short break? How much you need? 5 minutes. Is 5 enough? Okay, then 5 minutes, and then we will come back. And once you come back, then we close the discussion for today. And then, oh, by the way, another thing that is needed is there will be in-class quiz a bit later today. So you can already log into Socrative. You can see already the question. Don't answer yet because you might not know what is the correct answer, but we will get back to that a bit later. So 5 minutes. 5 minutes. So let me close this.